Good afternoon, learners, our learners from different parts of Dar es Salaam. I'm here today to teach you science as usual. I'm the science teacher, Mr. Silia. Please join me in our session. Our discussion today actually focuses on energy. The term energy has been used since class 1, and I know we know the meaning of this word. Well, just to revise, energy means the ability to do work. The ability to do work is energy. Now, we all know that for energy to be liberated, work has to be done. And therefore we say energy is the work done per unit time, or simply the rate of doing work. Now, in this definition, when you say energy is the rate of doing work, it means there's work per time, work divided by time. Okay, we'll learn more about this in our discussion later. Today, I want us to focus on energy transformation, or we say transformation of energy. Now, today I want us to touch only on two main areas, that is mechanical energy. Now, mechanical energy is divided into two. There is potential energy and kinetic energy. I have to note this for your sake. This is mechanical energy. Okay, so as I said in the introduction part, mechanical energy is divided into two forms of energy or types of energy. The first one is the potential energy. Potential energy, which is abbreviated by capital P and E, potential energy. Now, the other type of mechanical energy is the so-called kinetic energy. Kinetic energy. Now, kinetic energy is abbreviated by the form capital K, capital A. None of these letters should be small. So science has its own way of abbreviating quantities. Now, we don't have to forget this. Potential energy is a capital P, small capital A, and the kinetic energy, which is the second form of mechanical energy, is capital K, capital A. After having looked at these two types of energy, let us go to their meanings and definitions, of course. Starting with potential energy. Potential energy, basically, is the form of energy that a body has when it is at rest. If a body doesn't move, there's no movement, then this body is said to have potential energy. I'll give you examples for you to understand. If I stand still like this, and I don't seem to move any direction, anyway, I do have potential energy. When a duster is kept on the table, or a book is kept on the table, the book has potential energy. When you're seated at the sofa, you are seated there, you do have potential energy because you don't move. So as I said, potential energy is the kind of energy that our body has when it is at rest, it doesn't move. Now the second type, kinetic energy, on the other side, means the kind of energy that our body has when it is in motion. Any moving body possesses the so-called kinetic energy. So if I stand here and I have to make steps forward, 2 steps or 1 or 3, then I'm possessing kinetic energy because I'm moving. A train, for example, moving from Dodoma to Dar es Salaam, or the vice versa, Dar es Salaam to Dodoma, possesses kinetic energy. When a ball is kicked and it moves, it does have kinetic energy. An aeroplane flying from one destination to the other possesses kinetic energy. So this is the kind of energy that a body has due to motion. Now, in science, specifically physics, when you say a body, the term body does not mean a human body. Body in science means any object. It could be a piece of chalk, a bottle of water, a ruler, human being, a car, etc., etc. So science has its own ways of using words such as a body. So when I speak, when I was defining the terms, I said a body has. So a body is anything, anything. We don't have to confuse this. It has no confusion. Now these are the two forms of energy. Today, in the transformation of energy, I want us to focus on how potential energy can be transformed, can be changed to kinetic energy and the vice versa. We're not going to be restricted on the two forms of energy. We might mention some, but our main focus is the potential energy and kinetic energy. Now, this is very, very important. Now, because this is very important, I want you to really focus. You pay attention as I'll be giving you practical examples. Now, let us take a very good example of a body, for example. Let us say a glass. This is a table. I'll just make a platform to give you a knowledge. This is a table. I will not draw the whole of it. And this is the ground surface or the floor. This is the floor. Now, if a glass is positioned somewhere here, on top here, and so it is placed in a way that it can fall. When a small force is applied, the glass can fall from the tabletop downwards to the floor or to the ground surface. Now, if a glass is positioned at this point here, we say this glass has potential energy because it doesn't move. If there's no force applied to make the glass move from where it was, then we say the glass possesses a potential energy. We don't have to forget to say potential energy is the form of energy that a body has when it is at rest. It doesn't move. So at this particular point on the table, our glass here has potential energy. Let us label it as potential energy. Now, so potential energy is really affected by height. We have a simple formula for potential energy. I want you to get a concept here that potential energy by formula equals to mgh. mgh. Potential energy equals to mgh. mgh. In this formula, m represents the mass of a body. The mass of a body, not weight. Mass of a body. G represents gravitational force, or force of gravity. And then h represents the height of the body. So height affects the amount of potential energy. The higher the position the object is from the ground, the bigger the potential energy. This is very important to understand. So as I said, because potential energy is the product of the mass of an object, force of gravity or gravitational force, and height. Gravitational force is known, it is constant. and the mass of an object is constant, but the height changes. So it depends on the position of an object. An object here, the glass is positioned at a certain height. We cannot exactly determine the height. It could be anything, maybe 10 meters, or 6 centimeters, or 15 meters, etc., etc. Now, height normally means the distance from the ground, from the bottom to the top, to where the body is raised. This is very, very important to remember. This is the height. So height affects potential energy in a manner that I said at first, that the higher the position of the object, the bigger the potential energy. Now, coming back to what I wanted to explain, when a glass is here, it has potential energy. Now, when a force is applied, an amount of force is applied towards the glass so that the glass is pushed, then we don't expect the glass to remain in its normal position. The glass will automatically fall. Will automatically fall from the top of the table downwards. Now, as the glass falls from the top downwards, its potential energy is changed into kinetic energy. Why? Because the glass is moving. It is moving. There's movement there. The glass is dropped from the top of the table, or from wherever it is put. So it moves downwards towards the ground surface, which is the floor. Now, as it moves from the top of the table, the potential energy is converted into kinetic energy. Here, there's an energy transformation. Now, when the glass reaches on the ground, or the surface, of course, we do expect sound to be produced. When sound is produced, we say the potential energy is again converted into sound energy. So the energy transformation that we expect from this example is, now when the glass was on the top of the table, it had potential energy. And as it falls downwards, when a force is applied, the potential energy is converted into kinetic energy. These are the two main changes. Again, when the glass reaches down, of course we expect sound to be produced. So there is also sound energy produced. Sound energy is produced. Let me repeat this one for you people to understand it more. I said, when the glass is on the top of the table, or any raised surface from the ground, and it is stationary, meaning it doesn't move, it possesses potential energy. This potential energy is because the glass doesn't move. And then, as it moves downwards, when a force is applied, and so it has to fall from where it is, as it is falling downwards towards the ground level, this potential energy is converted into kinetic energy, which is the energy that our body has due to motion. And then when reaching on the ground, we do expect a sound to be produced. Automatically, when a glass falls down to the surface, sound is produced. So we say the kinetic energy is then changed into sound energy. But when the glass is on the ground, it again possesses potential energy. Then when the sound is heard, the cracking sound is heard, that is where the potential energy now is converted into sound energy. Now I have to repeat this quickly. On the top of the table, potential energy, which is converted into kinetic energy as it moves downwards. Again, on reaching on the surface, after some times the glass regains a potential energy because it doesn't move. Now that sound that we hear after the cracking sound of the glass is what we call sound energy. So we expect such changes. And this is what I meant when I say we discuss about transformation of energy, changes of energy from one form to another. After having looked at this example, there are several other examples to demonstrate this, but I would like us to talk a bit about the two forms of energy, which is my main objective today. I said the potential energy is given by the formula mgh. Now, in this formula, m shows mass of an object. Then G, small letter G, represents the gravitational force or force of gravity. Gravitational force or force of gravity. And then H, small letter h, represents the height. And the height means the vertical distance from the bottom to the top. Now, on the other side, coming to the second form of energy, which is the kinetic energy, we have a very, very useful formula for calculating it. This is very, very important to know, which says kinetic energy of any object in motion equals to a half mv squared. A half mv squared. In this formula, capital letter M represents the mass of an object, just the same as in the first case. So mass of an object, and V represents the velocity of a body. Remember we said kinetic energy is the form of energy that a body has when it moves. So we do expect a body to possess the so-called velocity. Now, let me write the meaning of each of the letters. M represents the mass of an object. V, small letter v, represents the velocity. Velocity of a moving body. Now, most of us might have problems with the meaning of the word velocity. Velocity is the same as speed in some ways, though it is not exactly the same as speed. Now, the velocity of a body means the speed of a body in a specific direction. If a body goes towards a direction which is not specific, we don't call it velocity, we call it speed. So the movement of a body in a specific direction, we say this body moves with a velocity and not speed. Now the difference between speed and velocity is speed is not taken in a specific direction, but velocity is in a very specified direction. That is the difference between the two. So when we talk about kinetic energy, we talk about bodies moving in a specific direction when the speed is specified. These two formula are very, very useful in calculations, which we're going to discuss in our next lesson. Today, I want us again to go to another example, a very small example, and I want you, wherever you are, try to find examples of ways in which you can change energy from one form to another. This is very, very important. Now, let us take a very, very simple example of a ball which is being kicked. The ball is in this position, or this place, and then somebody kicks the ball. This person aims at kicking the ball to this direction, to this specific direction. Now, when the ball is at this position, it doesn't move. We say this ball has a potential energy. Now, when the ball is kicked, we expect it to move to the direction intended. And as the ball moves, as it is moving from this direction to any other direction, say the right, then we say this ball now possesses potential energy. Another practical example is this duster here. I have it at this height, so the duster has potential energy because it doesn't move. As I allow it, observe what I'm trying to do. As I allow it to fall, as it is falling down, it has kinetic energy because it is moving from this position downwards. So there's a transformation of energy in this place. Potential energy of the duster when it was at this level, kinetic energy as it moves down. On reaching down there, the duster does not move. It is at rest. So it has again potential energy. This is very, very important to understand in our lesson today. We do have other energy transformation, but I find them so important when we talk about them in our next lesson. Today, I wish to end here, and I hope this part has been understood. If so, I'm so blessed. And I join my fellow teachers to say COVID-19 is a problem, a very big problem. And as learners, young learners, future scientists, future engineers, we really have to be precautious. There's no way we can get rid of the problem if we don't take precautions. Wash your hands with clean water, actually running water and soap thoroughly. Make sure you keep a distance so that you don't get this. And whenever possible, as you're moving to places with a lot of people, you name it, please wear a mask. Thank you so much for listening. You have a better day.